Hello everyone. So today we'll be discussing about negative dimensions. So I'll start the session in 2 to 3 minutes. Waiting for 30 seconds. No, okay. Okay. So today we'll be discussing about we'll actually explore the negative dimensions. Okay. So first of all, we will discuss about some of the prerequisites required for this. Okay. Even I expect from you that you know, but still I'll discuss with you about coordinate transformation and the basic knowledge of tensor. So that will be needed when we'll be discussing about the negative dimensions, concept of negative dimension. Okay, so I'll begin and I'm sharing the screen with you. I think the screen is visible. Okay, so let's begin. So our lecture flow will be that we'll first discuss about the coordinate transformation. Okay, we'll first discuss about the coordinate transformation, where we'll be discussing about first of all about tensor, and then we will be discussing about your how can we transform between one coordinate system to another coordinate system, and then we will be exploring the negative dimensions. Okay, so let's begin. So first of all, let's discuss about one entity, that is tensor. In last session we discussed about scalar vector. Okay, this is just advanced version, and even you can say uh, special type of entity, that is the tensor. Okay, so we'll have a discussion on tensor, and then we'll be discussing about negative dimensions. So what's actually the tensor is? So see, whenever we require to go from one coordinate system to the another coordinate system, we use tensor. Okay, so tensor is actually an entity that is used for the transformation, coordinate transformation. Obviously, we'll have some rules. We'll use some rules to transform from one coordinate system to the another coordinate system, and using that rules, uh, we will be transformed to the you can say another coordinate system. So we'll take an example to understand the basic code idea. We'll not delve deeper into this contravariant covariant vector tensor, but we will uh, have the basic idea. Okay. So suppose we have one coordinate system. This is your xy coordinate system, or you can say we are discussing real plane. So this is your y-axis. This is your x-axis. Okay. So this is actually your real plane. I'm writing by r dot p. So it's real plane. Then we have that is you say complex plane or argand plane. That is your here imaginary axis. Okay, let's say of z, and this is the real axis. Real axis of z. This is called complex plane. So what happened? If you know the basics of notation of complex number, then you know that this z is actually denoted by x plus iota y. Okay. So what happened actually here? That in the real, uh, you can say system, or you say the xy coordinate system, we have x coordinate and the y coordinate as the vertical and the horizontal axes, and all the points, whatever point you locate in this particular real plane, that would be of form x comma y. Yeah, but this concept is in real plane, or you can say the system where we are discussing about it. So, but when we transform to the new system, that is your so-called complex plane system. So here we are discussing, or we are explaining it in terms of a complex number z, which is actually not x comma y, or that is not x or y individually. It is x plus iota y. Okay. So how can we transform it? So we'll discuss about it. First of all, we have considered two planes, real plane and x plane. So let's discuss about it in more detail. Okay, just wait. There's an issue. Just wait for 1 minute. Okay? So we were discussing about the real plane and complex plane. So in real plane, we have xy coordinate system. In the this particular complex plane system, we have imaginary axis and real axis. Okay. So if you just make this particular z, just square it out. Okay. So what you'll get z square as x plus iy square whole square. So we are getting here. We are getting x square plus y square plus not plus here, minus. Okay, I think you know the operations of iota. Right. Okay, here it will be minus, and here we'll have 2 iota xy. Okay, this is the basic introduction. Okay, this is the basic introduction of considering the two planes, real plane and complex plane. Now we'll set up a transformation. How can we transform? Okay, so just have a look on it. Suppose we are given with this equation: y is equals to x square. Okay. It's given us in the real plane. We can plot it. Yeah. Real plane we can plot it. It will look like this. Okay. So y is equals to x square. Now how can we transform? Okay, that's the main agenda. So actually, when we have this particular y is equals to x square, our points are like this. Suppose we take x is equals to 0, so we have 0 comma 0. If we take as 1, we have 1 comma 1. So actually, we can go by this way. If we are in the Argand plane or the complex plane, then we have to locate it in this. Z is equals to x, suppose dash plus iota y dash. Okay. So what is actually here y dash or x dash? So actually here you have to make a transformation in a similar way. You can have, see, this y dash is nothing. First of all, this y only. Wait. Hello, hello. Okay, now it's fine. Wait. Yeah. So how can we transform it actually? This y dash is actually this y only. And this y is actually x square. So now this is your actually x dash, or x dash square you can say, where x is equals to x dash. So you can just transform it this way: z is equals to x plus iota x square. I will take some more examples, as I have some more examples here to discuss. Just wait, I'm taking some more examples. So this is the one way where you are given with the one, you can say, as y is equals to x square in one system, and then you can transform it by just substituting it, and then you will get the required result. Even we can parameterize it. Okay, we can take it as a parameter of t, and then we can just solve it. Okay, so that is also possible. Okay, so you can parameterize it also. You can take your own example where you can parameterize it, like we are saying that suppose z is equals to x plus iota when x is itself a function of t and y is itself a function of t. Then we can parameterize it, parameters will be given, then we can proceed further. The way the transformation, the coordinate transformation is simply that we are given with a certain relation in one coordinate system, and we will use that to transform or to convert it into another system. Okay, so actually uh, while discussing the coordinate system, okay, actually the dimensional analysis, when we do what we do, we discuss about the coordinate transformation. How? So suppose we are given with the two coordinate system, suppose k and k dash. So as I discussed with you in the special derivativity, if we are given with the two coordinate system k and k dash, we can make transformations in it. Okay, on the basis of the rules provided to us. Okay, so these whole concepts, what I discussed about the coordinate transformation in the real plane, or we say in another your imaginary plane. Okay, whatever plane we are discussing, the main thing is that we are able to do the coordinate transformation. We are able to transform it into from a certain coordinate system to the another coordinate system. So this will form as the basis for the negative dimension. So let's start with the negative dimension without any delay. So what's negative dimension is? What happened to the? Wait. Now it's fine. Okay. So negative dimensions. So what actually the negative dimension is? Just we will discuss about the two different coordinate system that I am discussing with you as k and k dash. Suppose we have two coordinate system k and k dash. K is your normal coordinate system where you are discussing the dimensions like 1D, 2D, 3D, 4D, okay, 0D. So that you are discussing. We have the k dimensional system where you are discussing 0D, 1D, 2D, okay, and up to you are discussing the 4D also. 5D, whatever you want to discuss. Okay. And now I made a statement, or I gave you the relation in this k and k dash system, that actually when you will define the k dash system, when you are defining the k dash system, actually these 0D, 1D, 2D, 3D, 4D will not work, but we will define a special dimensions in using some transformations. So that I am going to discuss with you. Like we will have that in this k dash system, in the new coordinate system, okay, because in the older coordinate system is simply what we discussed. 0D, 1D, 2D, 3D, 4D. Okay, that I discussed with you in last lectures also, and in the special derivative video also. But if we change the coordinate system to the k dash with one transformation rule, and that rule is here, that we are just taking this 2D equivalent. This is the sign of equivalent. See, there is a difference between equal and equivalent. Equal means, if we are saying suppose A and B are equal, means they are equal in each and every aspect that we can have for the comparison. But if we are saying equivalent, it means they look alike, they look similar, but they are not equal in every aspect. Okay, so in equivalence, while discussing the equivalent or while discussing equal, in equivalent we have, suppose we have 5 parameters. Okay, we have 5 parameters. A and B are satisfying all the 5 parameters and all giving the same result in all the parameters. Like while we compare through all the 5 parameters, A and B are giving the same result. It means A and B are equal. But suppose we have C and D and they are giving the 4 parameters and they are the major parameters. It is not lacking in the certain, you can say, one of the major parameter, but it is lacking the minor parameter. So if it is satisfying with the 4 parameters and that are major parameters, and or you can say the left one is not that major parameter, then we will say that C and D are equivalent. So this sign is of equivalent, that is triple is equals, is equivalent. So 2D is actually we have defined, this is our definition. This is our definition that we defined 2D as our starting study of dimensions in the new dimensional system, that is 0 D dash. Okay, so this is our definition. Okay, as I discussed with you, uh, while doing the transformation we need to give a certain condition or definition. So that definition I gave, that this 2D system, this 2D is actually equivalent to 0D dash, or you can say, see, the concept of negative dimension is not explicitly written anywhere. It is something that we can understand using the correlations of concepts of tensor, or you say coordinate transformations, and this the prior knowledge of dimensions. Okay, so we can have this just by making the coordinate transformation using our prior knowledge. Actually no one has ever seen the negative dimension, because what do you mean by negative dimension actually? See, when you are at 3D, you are with xyz axis. When you are at 2D, you are with xy axis. I'm taking one example, okay, one possible case of dimensions, 2D or 3D dimension. So what you are doing, you are just reducing your exploration when you are going from 3D to 2D. Not the size or length I'll use the word, but I'll say that we are reducing the exploration when we are going from 3D to 2D. Then 2D to 1D, we are again reducing the exploration. When we came from 1D to 0D, we are actually ending with a point which is dimensionless, that is in 0D system. And now something which we are getting dimensionless, how can we get something lesser than that? Because that's the minimum value, or you can say dimensionless. That is dimensionless means dimension is 0. Okay, so exploration was, if we discuss from 4D for a better understanding, if we discuss from 4D, you are with the force coordinates x, y, z, t. Then your exploration reduced in 3D and x, y, z you are discussing. Then in the 2D system you are with x, y or y, z or zx, just two coordinate system, you are just reducing your exploration. Then in 1D you are left with only single dimension, either x or y or z. When you are in the 0D system, you are left with nothing. You are simply saying that it's dimensionless. So you can say in the real world we can't have negative dimensions, but using the rules of mathematics, using the rules of coordinate transformation, using the rules of dimensions, using the rules of, or using the prior knowledge, we can devise this concept. Okay, we can devise for understanding, for getting an idea, a glimpse of negative dimensions. Okay, so that's the thing. Even my thumbnail is also not saying that negative dimension exists. It's, I think, are negative dimensions possible? So that's we are discussing now. That's a matter of discussion. Okay, so here we have just given a definition that 2D is equivalent to 0D dash. Means D dash is actually all the dimensional work in the K dash coordinate system. So they are two coordinate system. I think this is K coordinate system, KCS coordinate system, and this is K dash CS, that is another coordinate system. So we are just discussing. So if 2D is equivalent to 0D dash system, then what will be your 1D? Just see, this sign is also of congruence, okay, but I am not discussing congruence, it is equivalent. Okay, so don't get confused. So if I am reducing, I am just subtracting by minus by 1. Okay, so this will also subtract, so this will be minus 1. So actually negative dimensions are not existing. If we are discussing it's in original coordinate system that we discussed, 0D, 1D, 2D, 3D, 4D, it is not actually existing. Minus 1, minus 2 is not actually existing. But our definition, our interpretation is making it exist. So actually we have defined that this 2D system is equivalent to 0D dash system. So then 1D will be minus 1D dash, and then we can have the 2D also, sorry, 0D also. Because see, whatever coordinate system we are discussing, you will start from 0 dimension and you will go up to whatever you want, 5D, 6D, 7D, but we are discussing 0D, 1D, 2D, 3D, 4D. Okay, 5 dimensions from starting from 0 to 4. So we are actually giving the definition. We are actually giving the definition because we know up to 0D. Okay, in our original system we know up to 0D. We are just giving the definition in accordance with the you can say the given condition, that is the 2D we will consider as a 0D dash. So this will be minus 1. Okay, this will be your minus 1, and this will be your minus 2D dash. Actually it is not existing. Actually it is not possible in real world, but through coordinate transformation, through a definition, we can make it exist. Okay. Wait, what happened? Okay, yeah. So this is the thing. So that's 0D is actually minus 2D dash. So again you can write 3D as 1D dash. Actually your K dash coordinate system is you can say quite powerful, and even I can say that in your older system, okay, it is actually what you can say that it is actually if you compare with the from the K coordinate system, okay, K and K dash we are discussing. So actually it's 0D, or not 0D, it's 0 dimension of K dash is starting when the K coordinate system reaches to the 2D system. Okay. So actually what we can say here, that it is actually moving, our original coordinate system is actually moving in the terms of movement, we can say it is moving a little fast by 2D system, by 2D. Okay, by 2 dimension it is moving fast because at 0D, if we compare with the K dash system, we have minus 2D. So to reach to this 0, we require 2D. It's actually moving fast. Okay. Okay. So it is actually moving fast. Why? Because you are seeing that our definition is itself a proof that 2D is actually what? It is actually 0D dash. It is equivalent to 0D dash. So the older coordinate system, that is the K, is moving faster than the K dash system, which we actually, the dimensions we have actually defined. Okay. So that's the main concept of your negative dimension, and even you can move further also. You can discuss 4D system, that will be your actually in k dash coordinate system it will be just 2d dash. Okay, so suppose you are given a question. Okay, suppose you are given a question. Let me check that whether that sound is audible or not. Just wait for 10 seconds, 20 seconds. Let me check, because there was a network issue. It's fine. Okay, so what actually suppose I was discussing about the question. Okay, you are given with a question to draw suppose a a one dimensional coordinate system in k dash coordinate system. Okay, wait. Okay, so suppose you are given with a question that you have to just construct a one dimensional system. Suppose one dimensional system in k dash coordinate system. So what you will, that will be equivalent to the 3D system. You will just draw a older xyz and you will say that this is our one one d dash system. So that's the way you can actually define the negative dimension. So that's not explicitly written anywhere, but we can define it using the coordinate transformation. So the core concept is coordinate or dimensional transformation that we used here. Okay, so that was all for today, and I think you enjoyed the session, and we will see you soon in the next session. Thank you so much for joining. Bye bye, take care. So I'm exiting in 1, 2, 3. Okay, so I think you explored this negative dimensions using coordinate transformation thing. Okay, 1, 2, 3.